Good morning.
Hello, how are you?
I'm doing good. How are you?
Good. Turn that up.
Let's see here. All right, good. So we should be recording.
Okay.
And can you see my screen?
Yes, I can.
All right, perfect. All right, cool. All right, well, we'll go ahead and get started if you're ready.
Yes. Let's
Okay,
go.
so we'll kind of go through these little exercises um as you feel like you've kind of got it, right? So if
Mhm.
we right now I've got each one scheduled for every week, but if you're like, hey, this is, we can up this to maybe twice a week or something like
Mhm.
that, then we can do that. So
Okay.
um and as I go through as I create the curriculum and stuff, I'll try to combine some of it because I don't want to get like we don't need to get super far into the weeds on a lot of this. Like how to you need to know, like, for instance, what a brick tie is and why it's important, but you don't necessarily need to know exactly how you install it.
Okay.
That kind of thing.
Mhm.
So um and then that way you can, I mean, obviously if you're curious about it, you can always Google it or whatever,
Mhm.
um but anyway, so we'll kind of with this being our first time doing this, we'll kind of fly by the seat of our pants a little bit. So
Okay. Typically every Monday works for me. The only thing is just next Monday, it's I fly in to Houston at 11. So
okay,
that time is hard for me and I won't have a car, so I won't get back to my normal routine, I wouldn't say until about Tuesday. So that's the only thing. But other than that, all my other Mondays are pretty clear for all
okay, cool.
this.
Good. So we'll just, yeah, so just actually just go into the invite and just propose a new time for for
Okay.
next week. That'll be
Okay.
fine. Okay, so yeah, first thing we need to talk about is kind of learning civil plans. Because the civil plans are obviously the foundation of everything that we do when we're doing a ground up project, but they can also be kind of the most confusing if you don't understand, if you just look at them. If
Hmm.
you're just looking at them, sometimes it can be tough. So we're going to buzz through this PowerPoint, and then we'll actually bring up like some a set of submittal drawings, like maybe or excuse me, a set of civil drawings for maybe San Antonio or something,
Okay.
that we can actually kind of apply some real world theory to. Um, all right, let's see here. Um, so yeah, so basically we're going to talk about how to, and so one good thing is that the civil drawings are typically numbered the same.
Hmm.
It will vary from engineer to engineer, but usually there is a little bit of a standard there to where architecturally there's no standard hardly. So everybody just kind of makes up their own numbering system. The definitions will be very important. A sequence map is kind of what happens on a job. So like if we take a native lot, like imagine San Antonio after we demoed it, there was nothing there really.
Hmm.
Then what do we do in order to get the paving and the building foundation ready for installation? And then of course field verification. So that'll be some stuff that you'll get. A lot of your field stuff, we can watch some videos, we can look at that, but a lot of it's going to be just you learning in the field, maybe going at a critical time when we're actively putting stormwater into the ground, when we're actively building a building pad, that kind of thing. So let's see. We'll skip that. Okay, so hopping right into the drawings. So usually you have a cover page, you have an existing conditions page, which is usually 1.0. Sometimes you'll have like a zero point 0.1 for the survey. There'll be a survey included in the civil plans, which is your original survey. And then, of course, demo and erosion control those are usually always on the same plan because as a rule of thumb, so the first thing that a dirt contractor does when he gets on site is he installs the erosion control.
Okay.
Because that's your silt fence, that's your construction entrance. That is if there's any, so in the street, maybe there's like an existing stormwater drain that everything goes into. He'll install some swaddles and some stuff there. They're called BMPs, best management practices for stormwater. And that's like a whole nother lesson. Stormwater is like a whole nother, another deal because depending on where we are, it greatly varies on how much stormwater we do. So like I don't know if you remember, but like in Salina, they were very, very adamant about everything being protected because we were dumping, stormwater into new construction. So, or
Hmm.
excuse me, into existing into basically a new stormwater system. So they wanted to make sure it didn't get contaminated. So, and then of course we have a grading plan, which that's going to tell you what your grades are expected to be for your curbs, for your paving, for your manholes, for your catch basins, for basically clean outs, anything that you've got that you're actually installing on site, and then that goes into your utilities plan. So, and C 4.0 is usually the utilities plan. So, and utilities in this case is going to mean they're going to show where your electrical's coming in from the street to the building. They're going to show where they're expecting that your water's coming in, where your stormwater is either coming in and being contained, or where it's draining to, and also sanitary sewer. So wherever the sewer needs to go. And they have gotten this information. So the civil engineer will research and go to the city and find out, okay, where's your main for the water coming in? Where is where are we going to be able to dump your sewer? Um, so I'll go ahead and pull this up real quick. Let's look at, I think it's volume 1, maybe. All right. Well, that downloads will. So this is just kind of just a rule of thumb, right?
Hmm.
Just on usually your civil pages, they're going to start with a C. So
Yeah. Okay.
I think most of ours have. Occasionally, you'll get the civil set that does not start with a letter and it's just a number on a page,
Hmm.
but you'll be able to tell real quick, whether it's a civil set or not. So. um, So, we talked about the grading plan. So that's where your spot grades are. Your utility plan, we talked about that, that's your storm, your water, your civil details. You're always going to have a detail page. Now, a lot of these are going to be generic details. So for instance, like where we had, so for San Antonio, if we're doing, depending on how big the city is how much involvement they're going to have in our plans, right? Now,
Hmm.
the city of San Antonio, the city of Dallas, the big places, they have like generic details that the civil engineer has to use. And so that's why a lot of these details came directly from the city. And you can always tell that because it's usually on their own letterhead or excuse me, title block. This is called a title block. And the civil just pulls this from their website, pulls it from, in this case, this was from the SAWS database for their drawings. Um, but you'll always have some type of detail that tells you, like, for instance, this is how we're going to set our manholes. So, and this is where, the diameter of the lid, the diameter of the inside diameter, kind of where it's piped, all that kind of good stuff.
Okay.
And you'll read these just like a normal set of plans. So you would
Hmm.
look at, so like where you would have a cut view or something like that on a set of architecturals, these will have, so this is 4.0, and this is actually his site paving plan is 4.0. So there, we've already busted the standard. So um, let me see, here's 4.1. What I'm looking for is the utility page. There we go. So here's our utilities, everything that was coming in. So this information that I was talking about before that's not highlighted, so
Hmm.
it's not in dark black, came from the city. So they have water, gas, overhead electric, everything's running out here in this easement. And then that's where Hamilton tied on to it. So that's where he elected to, he probably had a conversation with the city, and the city said, look, you can tie on as long as it's anywhere out here. It doesn't really matter.
Hmm.
So then he ties on to it, wherever he needs to in order for it to be convenient, for us on site. But you can see here we've got here so this shows a manhole here that we're putting in. Also points to, let's see, construct so this is plus or minus 8 linear feet of 6-inch Schedule 40 PVC pipe, sanitary slope, and it gives you the slope that he wants on the pipe. So, and you can see that's going from the new manhole that we're setting to the existing.
So
Mhm.
just because that manhole, the new manhole is a black and then the old one is the gray. Typically the more highlighted, or I guess kind of the grayed out one, is the old, typically on plans.
Typically, yes. And you can
Okay.
always kind of confirm that with like, let's hop over to that was the demo page. Okay, so this is the existing survey. This is when the car wash was there, the old one.
Mhm.
Let's look at, so he doesn't really have, this is probably what it was, I'm guessing. So usually there's an existing conditions,
Okay.
and he probably used the survey as that, but the survey doesn't show us, like, because it could be confusing, like, how the hell do I know that manhole's even there?
Hmm.
Um, so that is kind of the only way to decide that is, like, for instance, this page here is his, yeah, this is his demo plan that he had made. And the thing that makes this confusing is that the demo plan typically, like, he's got this overlaid for some
Yeah.
reason with the car wash on it, the new one.
Hmm.
So it makes it super confusing. Um, let me pull up a different one.
Grab my charger.
Sure. Let's see if it's on here. So this is a good example of an existing conditions page. So
Okay.
this is between the demo, um, and they may actually, sometimes they do combine the two pages. I'm looking here to see if he actually gave us a demo plan. I don't think so. Yeah, so this guy, well, he sort of did. Okay, so let's look at this. And as you'll see, there'll be the civil plans, in my opinion, are the ones that you really have to pay attention to and you have to dig through, because you have to do the most research with these, as far as being able to understand them,
Hmm.
because they're so different. So here's the existing conditions page. So there were two houses that were on the lot. So you can see how these lots are huge. But
Hmm.
immediately I can already see that this is like marshland here, and he's got there's an existing wetlands. So immediately, if this were the first time I was looking at these drawings, and this would something, because this is a pretty big deal, so this would be something that would be covered in your handoff meeting, and
Okay.
it kind of was what we talked about last week. But
Yeah.
essentially, here is, and then it goes all the way, to the back of the property here. Looks like somewhere, we'll call it there. So, like, of this huge lot that they have, this is the only part that's buildable, is right there. Like,
Okay.
we can't even get on any of this. We can't disturb
Hmm.
it. In fact, in this case, there's some type of, not endangered, but there's some type of species that lives there. So they are going to be hyper sensitive to us building here,
Okay.
them being the city. Um,
Okay.
I'm sure the animals will too, but
Yeah.
um, anyway, so what you would see, so kind of combining these two, so like this existing manhole right here, um, well, and it does say EMH, which will mean
Hmm.
existing manhole. And it shows kind of where he thinks the sewer line was. And so kind of play this through a little bit and think about, like, closeout documents. when
Mhm.
we look, when we want to get as-built documents from plumbers and stuff, this is why. So
Right.
like he's going off of whatever was last turned into the city for this site.
Okay.
And this manhole may not even be there. He can
Hmm.
look on Google Earth, he can try to look it up, see if it's there. So those type of deals, when we're tying into existing manholes, catch basins, whatever, it's very important for us to actually determine if they're really there, number one, and number two, if they're in the right location. So this one could be, obviously it causes a big problem if this manhole's up here,
Hmm.
instead of right where he thinks it is. So
And typically you don't find that out until you have people on site, because 9 times out of 10, the civil engineers aren't going to go out and confirm. Like you said, they're just going to go based off of what was last turned into the city.
exactly. Yeah.
Okay.
Yeah, I would say almost 10 out of 10. There's especially if they're out of town. They'll
Hmm.
never even see the site
Hmm. Okay.
other than from Google. So
Gotcha.
um so anyway, so that kind of shows you a little bit on what, and there's still, and this is where doing RFIs really helps. So
Hmm.
if there's questions on, hey, what did you mean for this? What did you mean for that? It's where the RFIs come in and getting those questions answered. So and hopefully we will have done some of that in the pre-bid so that you would already have the answers for it whenever we go into the handoff meeting.
Okay.
Um, and of course, general notes, we've talked about compaction requirements, testing frequency. That's going to be in your geotech report. So all of these projects, whenever we're doing ground up, we have to have a geotech. And because
Yes.
that's where and you know what a geotech is. So when they go out and they bore, they pull samples and they kind of tell us what the existing conditions are. And then that's how they actually design the structural foundation for the building,
Okay.
and give like options there. So and then, of course, existing conditions with contours and utilities. Let's look at this real quick. Okay, so this is talking about now. This is a huge exaggeration. So kind of it kind of made this detail it's way exaggerated,
Hmm.
um, because you won't ever see something like this on any civil set. This is just to kind of explain to you what you're going to be looking at, or what you kind of have to envision in your mind. Okay. So we start with the existing site, and it's going to have bumps and elevation changes, and it's going to completely um, depend on whatever, like Salina, we had to cut a ton of dirt out.
Hmm.
Other sites, we had to bring a ton of dirt in order to build it up. But this is the main function of the civil engineer, is to determine, okay, when we build this building, especially if it's going on a piece of dirt that's never had a building before, where's all the water going? Like
Okay.
that's their main function.
Hmm.
So looking at this, so the green area here is what would be called a fill. So let's start from the top. So this would be like your finished. So whatever he determines your finished floor elevation is in the building.
Okay.
So let's say in this case it's 107.2. Then he'll go from that building and he'll go out to the site and kind of look and say, okay, these existing conditions where we've got all these rolling hills, where we're going to need some fill right here. So let's just, for depiction purposes. So this is where we would need fill in order to bring the site up. And then we're going to cut off this little top of the hill. So that would be a cut. So that's where we're going to cut and so all of this in the real world, what a grader is going to do is he's going to come in and he's going to make all this shit flat to start with.
Hmm.
He's going
Hmm.
to come in, make it all flat, and then they're going to shoot some grades, and then they're going to determine where this is, based on. So he would probably come in. Let me see if I've got my. So he would come in, and the first thing he would do is this right here. He would
Okay.
fill the site. Like I said, this is a huge. This is like a 6 foot drop. So this
Okay.
is a huge exaggeration. Usually it's no more than, and this is over a distance of less than 100 feet. So usually that's like maybe 2 feet. So your slope kind of looks like this instead, maybe
Yeah.
something like that. And then what he's going to come in and take that high spot, he's going to make everything level. So he's going to
Gotcha.
take, yeah, so he would take dirt from here and he would basically fill it like right here,
Hmm.
you know. And
Yeah.
then they'll shoot their grades, then they'll look at it and say, okay, so now we need to determine where the building pad's going to sit, and then that's where he's going to have work on whatever the geotech says as far as doing actually building his building pad. Um, let's see here. So that's kind of a like I said, this is going to be it's going to be a good video for you to reference,
Hmm.
but don't expect to like get all this information at once because it's going to be
Hmm.
a lot of information that we're going to throw at you.
Hmm. Yeah,
So
I stopped taking notes. I'm just
not
gonna
here.
listen and go
Yeah,
back.
yeah, yeah. That's the smart thing to do. Okay, so let's look at the next slide. Choo, 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 choo. There we go. Wrong way. Okay, so again, another completely exaggerated depiction. But this is kind of similar to where now we've got the existing grade, and maybe this is the new rough grade that we've got, and then it would show the building pad. But the main thing they're wanting you to focus on here is the rim elevation of your utilities, the flow line, and the invert. So you're going to see invert a lot on
Hmm.
drawings. So the invert is going to be where the water comes in. Let's look at, let me show you see if there's a cut view of a pipe. And again, they don't really, okay, so I'm not exactly sure what, so this is basically just a trench detail, but the
Hmm.
invert on a pipe is going to be right here.
Yep.
That's where your invert is. Basically, it's the bottom of the pipe because that's where the water is going to flow. Your flow line is usually the center of the pipe, but not a lot of like we don't necessarily reference flow lines because that could vary depending on the size of the pipe, right? So if it's
Hmm.
a 12-inch diameter, if it's a 6-inch diameter, if it's a 2-inch diameter, that center stays the same, but the invert changes because the pipe gets bigger. Um, so meaning that if this were a 12-inch and that were, so you can kind of see the centers would all stay the same, but
Hmm.
your inverts change. If it were an even bigger pipe, so
Hmm.
your invert changes on every one.
Okay.
And then to kind of look at this in plan view, so you would look at your. Let's see if they give us an invert. They should. Okay. Um, Not all of your civil drawings are going to be this crowded and confusing to read because you've got grades, you've got new grades that are here. So TC and BC, always pay attention to your that should be top of curb and maybe bottom of curb,
Okay.
but always look for and it may not be on this page. Of course, it's not. Because that would be too easy. Here we go. There's our legend.
Okay.
Um,
Yeah. I would refer back to that a lot of the times.
yes. Yeah, exactly. And I don't see TC and BC on here. Uh, nope. That's the landscape plan. It's not on here either. Yeah, this architect, I mean, this civil engineer just did not do a very good job, in my opinion.
And is this a project that's already done? I mean, not that it, oh, this is
No,
green
no,
water
this is Green Wave. This is
and
West
green
Bridgewater.
wave. Okay.
So, okay. So let's look at here. So if this is top of curve, bottom of curb, then our curb and 82.02 minus 81.77 is basically a quarter of a foot.
Okay.
So a quarter of a foot is going to be 3 inches.
Okay.
So there's a 3-inch difference in these elevations. So I don't know. I would have to probably ask a question on this, but I'm assuming that if we go to, so the next thing I would do is kind of go through and look for a curb detail. It's dumpster pad, utility trench. There's a curb detail. Okay, so this is, well, sort of. All right, so our 3 inches is right here. Okay, so that elevation that it's giving you is going to be from here to here.
Okay.
Well, that's not exactly the bottom of the curve, right? To me, in my world, the bottom of the curve would be right here
Mm-hmm.
because that's the grade that I really want in order to, because these are precast, so they're not pouring this into place. And you can see we're putting down we're prepping our sub base, then we're putting down a base coat. This is a base coat or a binder coat, but basically it's a base coat of asphalt first. And then we're going to come in and just set these curbs in place. And then we're going to pour the top coat right here on the asphalt.
Okay.
So you can see the curb. So our curb is actually from here to here. That's the tallest point of our curb is right here.
Mm-hmm.
So it's very critical. So that 3 inches that we've got doesn't tell us anything.
Okay.
And that's not something that's going to be like, I don't expect you to actually catch that, right? So
Mm-hmm.
because it's an atypical situation. Um, yeah, like bottom of curve being 0.25 lower, that means nothing to us because that doesn't tell me where I need to actually be graded. It should give me top of base coat. So, um, and maybe that's what this is. Maybe this is base coat and top coat instead
Mm-hmm.
of, I'm thinking top of curb, bottom of curb. It
Mm-hmm.
could be uh, uh, bottom of bottom coat and top coat. So again, if we had a legend, that would explain it to us. But
Mm-hmm.
we
Now, is that
we
something
don't have
that you
anything.
would ask, like go back and ask,
Yeah,
or okay.
yeah. So we'll ask that. So just for and the way we'll word that is we'll say, just to clarify, TC, like we won't necessarily call it out and say, hey, there's no freaking legend on the page. So
Yeah.
what is TC and BC? We'll say, to clarify, does TC mean top coat or and BC mean bottom coat elevations, or are those top of pavement, or excuse me, top of curb, bottom of curb? So,
Mm-hmm.
and then
Okay.
we'll let them answer it. Um, anyway, let's go back. I'm sorry, I got us off track. I
No, that's
was
okay.
looking, I was looking for the invert to kind of show us what an invert would look like on the page. And okay, here's one. This is one that he has marked up. Um, Again, it's difficult. I know that he's pointing to this trench drain. So the trench drain he's talking about is right here.
Mm-hmm.
He's pointing like to here somewhere, but so this tells me that the rim of the trench drain is 81.17. Okay, so that means when you talk about, so this trench drain, it looks like this.
Okay.
All right, and then they would dig out basically, and then you got your paving that comes up to it like that.
Mm-hmm.
Okay, so it's got a grate on it.
Mm-hmm.
So we'll say that's a grate on top of the trench drain, and then there's going to be a pipe that is probably, depending on the design, the pipe is either here at the bottom or it's over on the side, but either way.
Okay.
So when he says the rim is 81.17, he's talking about this point right here being the rim
Okay.
at 81.17. And then he says the invert is 79.2. So again, the invert would be right here. And that would be 79.2.
Okay.
Okay. So roughly that's a little bit less than 2 full feet. Because if we add 2 feet to this, we get to 81.2. and this is 81.17. So that's, we're not building watches here. So that's, if you're within 300ths, then, we're going to call it 2 feet. So when we look at, now this is important because when you go to look at your submittal drawings for the trench drain, you need to make sure that this would be 2 foot from the grate to the invert is 2 feet. And if not, then whatever they submit may work. We just need to be sure that we dig into it and make sure that it's going to work. All right. So that's one small example on like where you're going to have, you would do the very same thing with, let me look at, okay, this one's a little, it's a landscape page. Yeah, we're going to have to look at it here. It's just so confusing. He's got so much stuff on here. I tell you what, let's look at San Antonio. There's not going to be as much. At least it's going to be a little less. Okay. So, again, talking about if we go here, so here, Jeff gives you the actual flow line, and he gives you, and these are coordinates.
Okay.
So, which you don't need to worry about the coordinates. Don't worry about that. And really for your purposes, flow line, actually, he calls it this says flow line invert. Okay, which is different than the flow line, which is kind of what we've already talked about, right? So, but this would be the stuff that you're not going to spend just a ton. So this is kind of where the difference is between a PM and a superintendent too, right? Because the first thing he's doing is he should be reviewing this stuff. I'm kind of teaching you this, not that this is what you're going to review immediately, but just when the superintendent comes to you and says, "Hey, our flow line's not right," you'll at least know what he's talking about.
Yeah.
I guess is my point, right?
Yes, that was a common question that I had on each of the videos because I wrote down all my questions, and I think on each one I put one, give me an example of how I would use this, and I think on the grading plan, not too much. Calculating invert levels was not bad, or the proof roll, but on the grading one, I think I just was like, okay, I would not be responsible for finding these numbers, but this is more so teaching me how to, if I needed to, how to do it, but also in communication, I would know what someone was talking about.
Exactly.
That makes sense.
Yes, 100%. 100%. Because this is going to be stuff that you're only going to get, like actually finding the grades and finding this. It's you got to be in the field, and it's like real world application in order for it to click and make sense. Because it can be very confusing just looking at it on paper or trying to watch videos. So,
yeah, I was on my walk this morning and I was looking around because in the video he says the best way to learn is looking at the world around you. And I was like, that's a wetland. That's this, that's that, which I've done honestly for the last 4 years, ever since doing anything construction. But the videos can help point out things, but looking, putting your phone down and actually looking at what's around you, is always more helpful.
Exactly. That's exactly right. So that kind of, talks about invert, rim, of course, slope, that's your rise over run, right? So that's however, so if we've got, 100 feet that we're running and we want that to drop 2%, so, over that 100 feet, so then you would take, obviously 100 feet times 2% would tell you how much it should drop, just as, so 100 times 0.02. So you're talking about it's going to drop 2 feet over that 100 feet, which is going to be basically, if you wanted to do it. So most guys think about that. Most guys and girls in the field think about that in inches. So like for every, so 2 feet should be like, so if it's dropping 2 feet over 100, then that would be, so over that 100 feet, so 100 feet divided by 24 inches, or actually, would it be the other way? Let me do this real quick. 24 inches divided by 100 feet gives you basically a 1/4 inch per foot. That's kind of how they think about it. because, and the reason they do is because they don't, they don't have a 100-foot stick of pipe, right? They've got like a 20-foot stick of pipe. So they need to know over those 20 feet, how far does that pipe? So I'm attaching to one end, and then we're going to lay this in the hole. And where does that other end, when I shoot an elevation on it, where does it, how much lower does it need to be in order for that water to drain? So, but yeah, so you'll hear, but 2% is a very common, 2% is very common. If it's a lot of slope, you're going to be closer to 3%. If it's very minimal slope, you're going to be at 1%. But we don't like to do, we don't like to do 1% just because if you make a mistake, like it will drain at 1%. But if the field guy screws up and your grade ends up being like a 0.5%, then that's where you get the water that's ponding and doesn't drain. So, let's see here. All right, so that's talking more about this stationing. Don't worry about stationing. Nobody talks like this other than surveyors, where they talk about 2 plus 50 is actually 250 feet. Nope, nobody talks about that. So they just give you elevations, and then they'll give you slope. And you may see this from time to time, but like I said, it doesn't mean anything to anybody other than the surveyors, because of this right here. Instead of saying, STA station 2 plus 00 is to 3 plus 00. No, we say it's 150 feet. I mean, we use we're very common. So, all right. So, like I said, this. So the finished floor elevation, so this is kind of how you would read this stuff, right? Finished floor elevation is 312.50, which is, I'm not sure if you remember or not, but that's sea level, right? Everything in grading is all sea level. So in relation to sea level. And we need to slope 2% away from the building for the first 10 feet. Okay, well, that's no big deal because we know that slope is a 1/4 inch per foot. So we know that we're going to slope just over 2.5 inches. So if you take, so if we take 0.25, which would be a 1/4 inch times 10, then it's going to slope 2.5 inches over that 10 feet. And then storm line runs from, like I said, we don't say this. We don't say that. Rim elevation is 311 and flow line is 308.08. If that conflicts with proposed grading, we have a problem. So this is something that a superintendent may tell you. He may look at something and say, hey, he may call you and say, hey, we shot some existing grades, and the rim elevation right here is actually 310 instead of 311. So now our flow line is not enough, right? Because we decreased it by a foot. So this either needs to be deeper, maybe it goes to 307 or something like that. But he'll tell you, hey, we need to do an RFI to figure it out, basically. And then, maybe he's got his hands full. He can't exactly get on. It is on the superintendent to actually do the RFI and Procore, unless he's like in the middle of something and we need to get it out. He may ask for help, something like that. But so that would be where you would write the RFI. And again, I use ChatGPT or Claude or something to help me write them all the time and to kind of make it super simple. It works out very easy. Okay. So now we kind of talked a little bit about, the 10,000-foot view on utilities and stuff. So this is very important, and this is very, very typical, right? So this is going to be your demo. Anytime you're clearing, they call it clearing and grubbing. Anytime you're demoing trees, you're knocking down buildings, whatever, that's called your clearing stage. And then you're going to do your rough cut and your fill. So that's kind of where we talked about, if you've got an existing elevation that's here, you're going to come in and you're going to make that flat, as flat as it can be, right? And then once you do that, then you're going to do your proof roll. So the proof roll is very very important because it's going to show you it's going to show you where some of your weak spots are in your soil. So like for instance, that's proof, and this is not a good proof roll. Like we know we got a
Okay.
problem. So see how it just ruts up, completely,
Mhm.
and that's not going to be a good, that's not a good proof roll. Um, Something like this is much, obviously that's rock, so that's being compacted.
Mhm.
It's much better. And there's different ways to do a proof roll, right? Most guys will do it with their dump trucks if it's a
Mhm.
smaller site. So we can see that. Um, Even here, that's what they're doing, is they're proof rolling the site right there. And all
Okay.
they're doing is to see if if it'll maintain the weight. If it won't, then that's where we have to remove the soil, and that's where the undercut comes in. So you might have an undercut. So
Okay.
let's say, and so what would happen in the field is, let's say we do our proof roll, we read the geotech. It says, okay, it gives you the steps that you need to do as well. It's very clear in engineer language.
Mhm. Okay.
So you would do so the superintendent would do the proof roll, or the earthwork guy does the proof roll. We look at it and we're like, this is not holding up. Like we don't need to put any fill on this yet. And then we would probably call the testing lab out, who's doing the
Okay.
compaction, and we would ask them, say, hey, based on the geotech, give us a recommendation on what you think we should do. Then they will write the recommendation. And then if it's, and then at this point, from a PM standpoint, we're thinking money, right? This turns
Mhm.
into money, because the earthwork guy is going to have to dig out some of the bad soil, and he's going to have to replace it with some fill or some better material. Well, that it's going to cost somebody some money, and we weren't planning
Mhm.
on doing that. So that's, from a PM perspective, you're thinking money. Superintendent is not necessarily thinking money. Superintendent's thinking, let's get the job done.
Mhm.
So that's where we don't want him to kind of get ahead of us a little bit, and we start doing work that we don't have approval on yet. But so let's say the geotech comes out, the testing lab comes out, says, okay, I think we need to cut down about 2 feet. Let's cut 2 feet out of this. And it looks like it's actually only in this area. So maybe it's only 10 foot wide by 100 foot is the area that we need to actually work in, where we've got the bad soil. So they'll write a report, they'll send it to us. We'll have it priced, we'll get it to the owner, we'll get it approved. And hopefully all of this is taking place in about 24 hours, right?
Okay.
All of this, from the time we get the report until the time we are giving this contractor the go ahead to get it done.
Now, just quick question. In the
Sure.
video, the proof roll video,
Mhm.
they he pretty much gives you step by step on what to do, and they said, okay, so it was get the surveyor out to pin the locations of the building pad.
Right.
Um, Now he says get the building pad to the correct elevations, and then would you do a compaction test before doing anything so you can test that soil,
So,
or
so you wouldn't, so that comes when we get to this point here with the compaction and the
okay.
lifts. Yeah. So if we do undercut it, then part of what the report is going to tell you is that we're going to say, let's say they tell us to dig down 2 feet, and then they're going to tell us, you're not just going to throw a bunch of dirt back into the hole. Then you're going to come back up in 8-inch lifts,
Okay.
and we want each lift compacted. So and compaction tested. So that's where, if we do an undercut, then in order to get it up to where we need it to get to, just to get back to existing elevation, right? We're
Mhm.
not talking about adding or doing the building pad or anything right now. This is just to kind of get it back to existing elevation. Then we would do our compaction test to get it back to that area. And then the testing lab comes out. Obviously, they're doing the compaction test and they approve them, right then. And then if we get back up to where, okay, we're back up to our existing elevation, we're good to go. So it's back to, so it would be in this scenario, going back to where we rough grade. So when we're doing this test right here, so that gets us to the rough grade, right? Then we proof roll this, and let's say that this section right here was bad.
Mhm.
Then that's where we would undercut. We would undercut this down and then just build that back up to this level right here,
Okay.
right? And then once that's done, we get blessings on it. Then we can start our select fill with maybe our building pad and say, okay, Now we've got 12 inches of building pad and rock, or whatever else they've told you to put in there, in order to get to this point here where we're going to have final compaction test on the actual pad.
Okay.
And that would be before we dig for the foundation or before we set forms for the foundation.
Okay, but no testing would be needed until after, like you would do your proof roll first. You
Yes,
wouldn't
you
do
would.
any
Right.
testing beforehand.
Nope,
Okay.
nope, because it doesn't really do you any good to do the testing first, because you don't have anything to compact. Nothing's been compacted. That's part of the proof roll, is you're actually doing a little compaction test, is what,
Okay.
or compaction. So, but yes, that would be correct. So, and then of course, once you get to this point, then you have your handoff meeting with your concrete subcontractor, and you say, here's the pad, take a look at it and make sure it meets your standards. So, um, let's see, let's go to, all right. So this just kind of goes into more in depth, stuff that we've already talked about: the clearing, the rough grade, the proof roll, and the undercut. And then the select fill, of course, this is after we got, so the site's good. We know all the existing materials great. Then we're kind of looking at the paving. They'll go around and they'll shoot grades again.
Okay.
Once they get that done. Let me see if we can. Well, I don't really see a good picture, but um, well, so for instance, they would have these grade rods set all over the site.
Yes. Okay.
And then that would tell you, it gives you the existing elevation. And in this particular case, the C-62, that's telling them that you have a cut. So that tells the grader, when he's going through and looking at these and he's pushing dirt around the site, that kind of tells him where he, where he needs to grade to, kind of gives him a good idea.
Okay.
And then, so obviously, if it were, instead of a cut, if you needed to fill that, then it would be an F dash, however far it needs to come up in order to get to that elevation. So they've done that all over the site, and then that's where they'll actually set your building corners as well. It is very important that you don't want to set your building corners until you have the site rough graded and the proof roll's been done. You're not going to have like a lot of disturbance, right?
Okay.
That's how we end up setting the building corners 4 and 5 times, is because we set them too early and then we destroy them in trying to get the rest of the site right. So, so compaction and lifts, that's where you have the building pad. Let me see if there's a good. Okay, that's not a bad one. So that you can tell. So what they've got here. So this would be like a good example for a car wash, maybe. This happens to be a different kind of building, but so what they've done is they built the building pad. So all of this was building pad, every bit of this. And then so you can see that they have what they did. They actually went over, and a lot of your civil drawings and a lot of your geotech are going to tell you that, okay, if the corner of your building is right here, we want to overbuild that by 5 feet all the way around. So what that does is that gives them a buffer to play with, right? So you don't want to build that building pad right to the edge of the pad, because if something's wrong, there's a mistake, whatever, you want to have a little bit of a buffer zone all the way around.
Okay.
So then you can see here the difference in this. So this is the select fill material that was brought in to build up the center of the building pad. And typically it's the entire building pad. So maybe their overbuild is like from here out. And maybe this is something else that I don't necessarily know what it is, but maybe it's not like a footing or something, in that regard. But you can clearly see the difference in material. Like all of this is going to be native, and then all of this is going to be structural fill. that they
Okay.
have put back into the building pad. All right.
Okay. And there's a photo right below it, where you can see the difference. It was a different one, but I see what you're saying. Like you can tell, yeah, that one
Yep.
that was brought in.
Yep. Exactly.
Gotcha.
Exactly. So ideally their footings and their foundation walls and whatever they've got, gray beams or whatever else, are going to go inside this area here.
Mm-hmm. Okay.
So, but this is like ready to go. It's ready to roll. And consequently, along with say this in this scenario, you're not going to have. So when they come out to set the building corners, something you'll often hear is, "What do you want your offset to be?"
Mm-hmm.
Like, so if you're setting up, maybe the surveyor, maybe the super calls you and says, "Hey, we need to get the surveyor out here to set our building corners. Let's set them up with 10-foot offsets." So what they'll do is they'll come in and let me go here. Let's go to here. So then what they'll do is they'll come in and say, "Okay, so here's a building corner. There's a building corner. There's a building corner, and there's a building corner." So they'll stake out just maybe where the exact corner is, but
Mm-hmm.
then they're going to come off of this 10-foot that way and 10-foot that way, and that's where they're actually going to put their stakes.
Gotcha. Okay.
Yep. That way you don't, because when they're working in here, they're going to tear these up, right?
Yeah.
But they'll be able to pull a string line from here all the way down, and it's going to tell them exactly how they, it's going to square their building up.
Mm-hmm.
And they'll be able to work off those string lines. Or you'll have a subcontractor that'll have actually a total station, and they don't use string lines. But same purpose, they're just, all the string lines are GPS now. So,
Okay.
All right, let's see here. Let's go back to our presentation real quick. Okay, and then fine grade, of course. So for a building pad, your fine grade is not done until you're right before you go to set your forms for the foundation, for the actual slab. And there's an important distinction here, and we'll get into this, I'm sure, more when we talk about concrete. But so if you have say that's your elevation of your subgrade, and then what you've got is you've got a concrete slab on top of that. Right? So maybe this is 4 or 6 inches here. So this is your slab. When somebody says slab, that's your slab. That's your finished slab.
Okay.
When anybody says foundation, then that's going to be like maybe your footings that you've got that are below grade. And then like on our car washes, a lot of times these footings have foundation walls that go with them as well. But all of this is your foundation.
Okay.
Technically. So when somebody says slab, you're talking about just the top 4 to, that top last piece. When they say foundation, that's when we're talking about footings and foundation walls, grade beams, whatever all the rebar is underneath for the, that basically make up your footings and your foundation. But you won't have a fine grade on your actual building foundation until all your utilities are in, and they cover it up, and then they'll come in and grade it, just a fine grade with some sand to get it where it needs to be, and then they'll form up to pour their actual slab.
Okay.
Let's see. Yeah, so this is just pass and fill on a proof roll. So obviously no visible rutting, no deflection, no water is a big one. If you see that it's squishy and maybe it's, a lot of times what'll happen too is if you rough grade a site and then before you proof roll it, it rains on you. Well, it's very important that we kind of let that dry out.
Mm-hmm.
We have to let it dry out, or else it's going to give us a false reading on the proof roll, right? You can't, you're going to rut it up. It's muddy. I mean, it's
Mm-hmm.
obvious. So the site does need to be dry. Let me see. Deflection. Yeah. So proof rolls are pretty, it's not something you're going to spend a ton of time on. And it's something that you only do once a project, and it's over, but it is very important. So, and oftentimes it's just enough to ask the question, when's your, like, if you look at a schedule from a 3 week, so here's where it would apply. If you're looking at 3 weeks look ahead for a superintendent, and you see us going from demo earthwork all the way to building pad, then
Mhm.
you're like, where's our, when are we doing our proof roll? Like, when are
Mhm.
we, just so I understand, when do you have the proof roll scheduled? And, well, we kind of need to see that on the 3 week look ahead. We need to see the
Mhm.
steps, that we need to take. So that's kind of where it would apply from a project manager standpoint.
Okay.
Um, let's see. Okay, this is a pretty important slide because this is going to trigger your civil change orders. And so it's super, super important when we're doing the dirt work ourselves, which we're going to do more and more of. But also these are things that you can expect to get a change order from a subcontractor. So um, the first two are the most common. So unsuitable soil. So even though the geotech may be, typically the geotechs are pretty vague, and but we may start digging out, removing some existing utilities or something, and find out that there's a lot of organic material. Maybe somebody went and dumped, some asphalt, underneath that you couldn't see until you get to it. Okay, all that has to come out. Any organic material has to come out,
Okay.
especially if it's in the building pad. Rock is another big one, especially up north and in, central and south Texas. Tons of rock everywhere. I bet we probably spent $20,000 on rock excavation in San Antonio. Just we got no way to know that it's there.
Yeah.
And more importantly, so there's two reasons behind that. Your geotech may say that there's rock there, but you never know. Like, one boring may show it at 7 feet, one boring may show it at 2 feet, one boring may show it at 10 feet, you know.
Mhm.
So, and it may not be net. So if it's in the 10 foot area and you happen to be excavating there, well, we're going to be good, right? So there's no reason for the excavation subcontractor to go ahead and bid removing rock unless he actually hits it. So that's why the rock it's always excluded, and it always ends up being a change order,
Mhm. Okay.
because we never know how much we're going to hit and to what
Mhm.
extent.
Mhm.
Groundwater's a bigger one, depending on where you are and how deep we're having to excavate. But not only groundwater, but also, say if we get a bunch of rain, that's called dewatering. Whenever we go in and we will dewater the site, so we got to get this. So a site dries up a whole lot faster when there's not standing water.
Mhm.
So they'll go in and cut trenches. They'll go in and cut, to get the water off the site. They'll go in and, of course, we got to be careful where we're draining it. That goes back to stormwater.
Mhm.
And they'll also take and put pumps in. We've gotten pumps thrown into the bottom of the hole to get the hole pumped out so that we can actually, maybe it's, sunny for the next couple of days and it dries out and we're able to go back to work. Utility conflicts, that's usually only a change order if there are existing utilities. So if we're putting in all the brand new utilities, usually that's not a big deal.
Mhm.
If it is, then somebody screwed up. Like,
Mhm.
we've done something wrong. Not necessarily us, but maybe the subs have.
Mhm.
If you've got additional structures, of course, being catch basins or existing, on a lot of these sites, we find existing grease traps that nobody knew about that we happen to hit. Again, that's all going to trigger a change order. Any owner scope growth, so that would be, any parking ads they want to make, basically anything on the outside of the building pad that they want to add is would be on them. Any errors or omissions, that really goes across all plan sets, not just civil. Errors and omissions, is that's architectural, structural, that's everybody. And of course, testing failures and retesting. So most of the time, or all the time, if the testing lab charges us for extra testing and it failed because maybe a subcontractor had it tested too early, or maybe it just failed because of poor workmanship, then they would be back charged for that, right?
Mhm.
So it's not something that happens a lot, because usually if it's a retesting fee, we very seldom see it. But if it's a reinspection fee, maybe we have to pay it with the city, and it might be $50, something like that.
Mhm.
Now, to me, $50 isn't worth processing. We pay it and go on.
Yep.
But if it's 500, 1,000, something like that, then obviously it becomes a bigger deal.
Mhm.
Documentation is the same as what we require on any other change order. So, your photos, your change order breakdown that you'll need. Even if we're performing our own dirt work, we still want to do the change order breakdown just for your future reference. And then that includes any receipts. That's where your trucking tickets will come in. And that's bringing material in, taking material out. Obviously, that's pretty much the same across all change orders. No documentation, you don't get a change order. So it has to be documented. Let's see here. Okay. Let's see. Inspection, hold points, schedule constraints. Yeah. All right. Let's take a look at, we're not going to worry about these labs or anything like this. Let's talk for, so does it make sense what a benchmark is? Benchmark and control point are the same thing.
Okay.
Did it make sense what a benchmark is when you looked at when you watched the videos?
Well, to be honest with you, I don't know if I heard the word benchmark once. I mean, unless it's another word, but.
Let me show you real quick. So benchmark and control point both mean the same point. So you want all your subcontractors working off the same point.
Yes.
Basically. That's how they establish building corners. That's how they establish everything starts from the benchmark. Now.
Well, in the past, so I could be thinking of something completely different, but maybe it was in the meeting last week. I think maybe you had said there's a benchmark on the tree. One of them said that there was a nail in the tree.
Yes.
So like that, so pretty much it's a point on whether it's the stakes or whether it's something that's already been there, like trees. You can benchmark off of that, and that just keeps everything in place. Because I mean, I know from the past of all of the projects, I remember hearing the benchmark was removed or it got moved. So then that screws it up. But you want to keep your benchmark in the same spot so you know exactly where your entire building pad is.
Exactly. So, and then once that building pad is poured, then that becomes your benchmark. Like, hopefully you're done with utilities. You're done, excuse me, by the time you get to that point with all your utilities. So like, yeah, this is exactly what we were talking about. So this catch basin here this is actually outside the curb. No, it's not. It's actually inside the curb, but just in the easement. It gives you a rim elevation of 83.14 as benchmark number 1. This one down here is benchmark number 2. It's a nail in a tree at 82. Okay. That's the one we're not sure if it's still there or not. This one's probably still here, but what we need to do is verify the elevation. So we need to verify that 83.14 is actually accurate. And the surveyor will do that. He'll verify that that's good. And then the superintendent could decide, well, do we want to keep that benchmark there so you always want your benchmark, if at all possible, it's in one spot and it never moves.
Yeah.
Because if it moves, then you've got to transpose the location. Then you've got to let it, and then it becomes, it could create human error. Right. So, that's why typically we will always do it. And like, maybe there's an existing tree that we know is not moving. It's completely off the property. We'll go over there and the surveyor will put a hammer in there, put a nail in there and say, that's your finished floor elevation right there. And now, based on that, like for instance, our finished floor elevation is 81.34 for the building. But everything else is driven off of that. Everything else. So, but yes, it's always verified, but that's your starting point. In big sites, they'll have multiple control points.
Yes.
So if it's a huge site, several acres, then they have multiple control points because you'll have different guys working in different, and when they set their instruments up, you don't want them interfering with each other, so, which can happen. So, but yes, that is and so just remember the benchmark and control point are the same thing. They're interchangeable terms, and it's your starting point. It's what you always start with on the job.
Okay. And that's what like you've said, that's what you want to avoid messing up because 9 times out of 10, then you're gonna have to call somebody. It just is money.
Yes, absolutely. It's money. So if you use a benchmark that's in the middle of the site and it gets destroyed,
Yeah.
then, and the utility guy comes to you and says, "Hey, boss," well, goes to the superintendent and says, "Hey, boss, the benchmark's no longer there. Now you got to have him come reset it." So,
And if you don't
um,
catch it and work's been done, then you have to redo the work.
yeah, verify the work and then redo
Yeah.
it possibly.
Yeah.
Hopefully not, but yeah. Um, let's see, identify one critical grade spot and explain what it controls. Now let's look at, I don't know that either one of these examples are very good I would like to show you. Um, it's not real good. Uh, it's got to be on one of these. 1 second. Let's look at, okay, this is, again, tough to read because it's got a lot of shit on it. But what he's got drawn here, it's all buffers. Okay, this is better. Well, I don't know if it's better or not, but it's something. Okay, so this is showing you like something that you need to probably just practice. And that's the only way you're going to get it is if you practice. Like I can look at this and tell you which way this thing's sloping.
Okay.
So I can look at it and say, okay, there's 74, there's 76, there's 78, and there's 80. So I know like I'm going to say from this point, I know we're sloping at least this direction. Now, so so now we got to determine which way. So is all the water coming to the back or is it going to the street? Well, you would think that it would go to the street, but let's look at the street elevation. This is all existing, by the way. This is how the existing site was.
Okay.
So we're 80 here. We're 80. So this, something else you got to so this is a different way to write 81.70.
Okay.
Yeah,
I would have looked at that and thought that was a math problem, to be honest with you.
I know. No, it's 81.70.
Okay.
Just like this is 83.14, that's 81.70. This is 80.19. This is 79, da 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 da. So I can look out here and I can tell you that, okay, this is actually sloping. So I know that my street elevation is all going this direction because I'm starting out here at 84. And don't ask me why they write it that way. I have no clue.
Yeah,
I'm sure
strange.
I'm sure there's some explanation that's, somebody with an engineering degree has, but I can tell that I'm high here, I'm low down here. So I know that this thing is sloping this direction. All right. So basically, from what I can tell, all the water is, I put which way it's sloping upwards. It's easier to think about it by which way it's sloping down.
Okay.
So we know that then there's probably, if I had to guess, there are no elevations here. I could be wrong. Nope, there is an elevation. Okay, way out here, so 70. So basically from this point to this point out here somewhere, it's basically dropping 4 feet, however far that distance is. And it's dropping another 2 foot from here to here. So this is all coming in, like it's all sloping like this direction toward the bottom of the marshland.
Okay.
So it's all sloping this direction. This is sloping this way. I can look on the street and I can see, okay, well, there's a curve dimension of 83.66. Directly across from that is 84. So I know that this is sloping this way as well. Which makes sense because there's a catch basin. So it's probably, so the water, so if you think about it, currently none of this water is, and that's probably the reason we have to contain all this water and none of it can go to the street because none of it's going to the street right now. It's all going back here to this marshland, every bit of it. Let's look at San Antonio real quick. Let's see. Should I delete that? Okay, this is a pretty good example. So you can see the closer the contour lines are together, the steeper of a slope it is. So you can see from here, like we know that there's a big, this is the creek back here. So we can see that this thing is sloping from 992 all the way to 982 in just this little bit of distance here.
Okay.
So that's a pretty good drop. It's a 10-foot drop over maybe 100 feet, which is going to be about a 10% slope, which is big. So you think about slope, that's the difference between, a 2% slope is going to be something like that. A 10% slope is going to be something like that, somewhere in that neighborhood. Just to give you just an idea. But that's kind of how you can pay attention to some of the contour lines as well. You can see that it's dropping 12 feet from here to here, 980, 992. But I always think about it in how the water falls. Where is the water falling to? Not where, because water doesn't necessarily. I've seen water run uphill, and it's a weird thing, but it happens on roofs.
I don't know if
sometimes,
I've ever
believe it or
seen
not.
that.
It happens on a roof sometimes if the roof doesn't have enough slope. It's the craziest thing. But anyway, but I always think, okay, where's the water draining to? Where is it draining to? And a lot of times, like we're not going to, like you wouldn't spend just a ton of time on looking at your grades. Again, the earthwork contractor is going to tell you, hey, bud, we've only got like a 1% slope back here in the back. What can we do, in order to change that? And then that's maybe where we do an RFI. So
Okay.
that's where it might be kind of applicable. Identify the drainage path. We've talked about that. Find one utility and discuss crossing. Okay. Crossings and scope gaps. Let's look at San Antonio because we did have a little bit of an issue. All right, that's our paving plan. Here we go. Okay. Something to always pay attention to is your utility crossings, right? So what we've got here is we always like to identify our gas line, which is going to be typically yellow. Okay. Now let's identify our water, which is going to be blue. So there's our water line coming here, coming here. What does our water line do? Looks like our water line continues to there. Okay. So it's got our water line coming into the building right there. Next, let's look at our sewer. I like to use green for that.
Now, are these just what you normally you just pick any color and that's kind of the legend you go, or like that's what you just go off of, or is this the color of like does the colors matter, I guess, in this situation?
No, but if you use yellow for anything, it's always a gas line. Like it's just a known thing. Like so, and where that comes from is when they come out to stake. Like when you call 811 or something and you want them to stake where the main is, maybe on the road, they're going to use blue stakes for water. They're going to use yellow. The gas company will come and set yellow stakes. They'll paint with yellow paint. So it does mean something. Sewer can be interchangeable. Sometimes it'll be blue, sometimes it'll be green. For our purposes, I'm going to use green so that we can see that comes down here and then it goes to there and then it goes to there and there. Looking here, these are all, see, this is what you got to put. See, these are all lines going to the boxes. So those mean absolutely nothing. Let's see, those tie into that. Where's my sewer? So my sewer is actually existing here. and ties into, that's that existing manhole that we've already got.
Okay.
Okay. So this is why it's important for utility crossings. Now, if you ever have a problem with this, first of all, he shows this coming into the building right here. That's not where that comes into the building. Or if you look at our plumbing drawing, our plumbing valve and RPZ are down here. That's where they come
Okay.
into all of the Smitties, is right there. You can walk
Okay.
into any one of our, any one of our buildings, and damn it, and they're going to be right there. There we go. So what happened was so we should be getting an as-built drawing from Plumrite, because this is actually going to be here. So not a big deal.
Oh, okay.
Right. They just extended it down and went ahead and ran it into this side of the building. So that does two things. One, you don't want to run this thing near your reclaim tanks, because that becomes a pain in the butt if you ever have to get to it, ever.
Yeah.
So we ran it down here to keep it out of the way. The other thing that's the problem is you don't ever want the gas line in your reclaim tank area. So we ran this gas line actually from here, we ran it out there, and then got outside the curb and then took it to the street like that. So we didn't necessarily run it like this. It's a lot easier to cross these lines because these are going to be a lot deeper than trying to mess with all the piping that's here for your reclaim tanks. It just gets it completely out of the way. So that's something that you can think about. This is specific to a car wash situation, but it would be anything else as well.
So, sorry, out of just curiosity, so in the videos on Trainual, you said that project manager typically gets about 3 days to go through the plans and study and read every single detail. Now,
Yep.
is this something that if I get a set of plans and I'm reviewing and I see, okay, it's crossing over on these drains, and we know we're not going to do that because of prior projects, is that something that you can then go ahead and have a markup done to avoid running that into construction? Like while you're reviewing the plans as a PM and marking them up, could you already bring that to the table and say, this is an issue that I'm already seeing now. Let's go ahead and plan to avoid that down the road?
1,000%. And
Okay.
I would do that. So every time you come across an issue, what I would do is make a list of those issues, and then you would have a separate meeting with your superintendent that says, hey, have you had a chance to go through these drawings yet? Here are the things that I'm kind of seeing, but we need to get together and talk about these and get these to the, identify which ones I think might be issues and which ones you tell me, no, don't worry about it. We'll be fine. We can run that. Or maybe there's really no other way to run this. We have to run it there, and maybe that's why they drew it like that. So I wouldn't issue RFIs based on your first notes from those first 3 days or so. And that 3 days, right, is for like a seasoned PM to go through and review drawings, right? That's not necessarily, I'm not expecting you to be able to review one in 3 days and have all your that's it's. But as a rule of thumb, you spend about, and when I say 3 days, I mean 3 solid days, right? Because you're not buying anything out, but as you're going through the drawings, you're kind of thinking in the back of your mind, okay, when I write the electrical scope, I need to be sure to include this, or when I write the structure, include this. Maybe it's something that's a little out of the norm. Because you would have already, so like for a car wash, for example, you would have already read through our scopes, and our standard, scope templates that we've got. And, everything's pretty much covered in there, but maybe there's something that's like, maybe this one has a dog wash. We've never done one with a dog wash. So maybe that's one you can say, oh shit, I need to make sure that I include the dog wash in there. I'm sure they probably did. And technically, if we just say, yep, your response, we can always hang it on them. Like, no, you had that because it's part of the drawings. But I like something that specific. I like to go ahead and call it out. It at least highlights it in the scope, so. But yes, 100%, make notes as you're going through them, and then that's where you would get with your superintendent and say, hey, have you had a chance to review these drawings yet? And if he says no, you need to make time. But two, we need to go over this, and we need to go ahead and get these questions out in front. That's part of being proactive. The more stuff we can kind of come up with and ask up front, the more clarification we can provide, and the more successful we're going to be. But no, great question. One thing I do want to point out that they do not show here. Well, they kind of do. Yeah, they do. Okay. So this is something that changed. And on our sites, it changes fairly, but it's always on us if we want to change it. So in Smitty's, something we did a long time ago was to try to avoid putting in those big transformers, like we've got in Lufkin, big transformer that's sitting out front. Not sure. Do we have that in Lufkin actually? I can't remember if we had the big green transformer or not, but anyway, point is, so that's he does have that drawn here from this existing pole, and he's got it completely outside the curb, which is great. And then we got a transformer set right here. Okay. Sometimes if he sees that there's power out here, maybe he would have routed this. See, this down here is a OHE. That's overhead electric.
Okay.
So we know there's a power line out here somewhere, right? That's actually where this pole is getting its power from, is right here. Okay. So for this site, yeah, that made total sense. If it was different, you'll need to pay attention to where they're running that electrical, because it could be coming from way out here all the way over here. It could be coming here. And again, that's another utility crossing. I don't ever like to cross my water and my electrical for obvious reasons.
Yeah.
But I don't, one's always deeper than the other. It becomes a pain if you happen to get a hole in the conduit, if you have, or a pinhole, whatever. It just avoids the problems, right? If we're able to do that, but always pay attention to where your electrical is. Now, what we did on Smitty's was we eliminated this transformer here, and instead of having it on a pad mount, so let's go to real quick. I do want to explain this. Yep. So this is the pad mount transformer right there.
Okay. Yep.
Okay. So that is what is being shown right here. Okay. Anytime you see that, you know that is a pad mount transformer.
Okay.
All right. Now, the difference is, so this is always fed from a pole. And again, I'm sure we'll probably get this into this when we talk about electrical later on. But so this is pulling from here, right? There's a pole out there. It's got a transformer on it. The conduit is run from underground. Let me see if I've got I know we've got thousands of pictures of them somewhere. Let me see. Well, that's where they're trenching the one. It's not a very good depiction. Okay, that's a better one. You've seen stuff like that before.
Yeah.
So that's running from something outside it's going up the wall of the building to another part of the building. So think about that in the same way with the transformer. So on the transformer pad, so you would have that's what UGE is. So that's your underground electric. So you're running underground from here to here. And then you would run more underground and it's that the P stands for primary. So primary underground electric. And primary means that is all on think about it from same thing as like an easement or like public versus private land. So primary electric is all part of the electrical provider. So this is EverSource in this situation. So we do install the conduit for them, but they pull the lines, they set the transformer, they do all that. Now, what you would have is from here to the building, you would have the secondary underground electrical. Okay. And that's going to go, and that would go from your transformer and stub up inside the building. So that would be what you're seeing on that one. So let's say that this is pretend that was coming from a transformer. That's what you would see inside the building. So this would be your secondary.
Gotcha.
So,
Okay.
yep, secondary just means we pull the wire. Our electrician will pull the wire and not the utility provider.
Mm-hmm.
Okay. Now, that's scenario number one. That's the most popular scenario everybody draws. Scenario number two is that you eliminate this transformer here. And instead of having just one pole mounted transformer, you might have 3 or 4. And it's already dumbed down in whatever, the municipality is bringing you. But let's say that this is the same thing as the pad mount, except it's in the air on a pole.
Okay.
So then our conduits will go from the pole to a meter that's on the building. And that is your secondary at that point. So I'm sorry, that I misspoke. That is still your primary because it goes to the meter. So that's another way to think about it, is like everything coming from the power supplier to the meter is all them. They take care of all that. They're responsible for the meter, the lines, the whole 9 yards. Everything after the meter and all the electrical after the meter, we're responsible for.
Okay.
So,
Patrick and his guys aren't going to get up and mess with that pole.
Correct.
The utility provider is going to handle that. And then once they're done, then they're going to come in and do the rest for the building.
Exactly.
Okay.
Correct. Yes, absolutely. They will never, ever, ever touch a pole. Huge liability.
Mm-hmm.
Huge liability. So yeah, nobody will ever touch that. All right. So that kind of talks about a little bit about the utility crossings, and it can get some sites are super simple. Some sites are very complicated.
Mm-hmm.
Just kind of depends on what we're doing.
Mm-hmm.
Let's see here. All right. Observe compaction and proof roll, documents pass, fail. Okay. Yeah, that's good. I think we're good there. Let's see. So compaction require. So yeah, let's buzz through this. This might be good to kind of find any holes that we've got. So if you wanted to find your compaction requirements and how often you need to be testing, where would you look for that?
I'll be honest with you. I need to have this. I feel like I need to have a Sybil set to know the page numbers, but the grading plan.
So it's not going to be on your grading plan. This one would be in your geotech.
Oh, okay.
It might be on your civils, but most of the time the civils will refer to geotech. It'll have a note on there that says refer to geotech report, So your geotech report, like when I get a set of drawings in, the very first thing I do is look at the geotech. I go through and I read it, and I'll read it and then I'll upload it to ChatGPT, and I'll say, hey, identify anything that seems to be out of the norm on this geotech report. And as I'm going through and reading it, I'll go back after I've read it once. I'll go back and look at the ChatGPT stuff and see if it's actual stuff that, because it's going to call alarm to everything that's in it. And so I'll go back and see which ones are actually things that we need to be concerned about. FFE, remember what that is?
Yeah. Field, final.
Close. Finish floor elevation.
Finish floor elevation.
Yep.
Okay.
Finish floor elevation.
Okay.
Which is going to be always your building slab. Okay. It's going to be, they don't say that there's another finish, like your parking lot's never finished floor, nothing else is ever finished floor. It's always your slab. And it will depend on, like on our car washes, we know it's the bare slab, right? You will need to, usually it doesn't matter that much, but you just need to confirm whether that finished floor elevation is before or after whatever the finish is that's going to go on the floor. So like if it's a building, you need to make sure that that's the actual concrete elevation. 99% of the time it's going to be the concrete elevation. So Um, yeah. So invert. Remember what the invert is?
Yes, it is the bottom of the pipe.
Yep. Bottom of the pipe. Absolutely. Where the where the water flows. And
Yes,
obviously that's important because of, shit's got to flow downhill. So
yes.
we don't want to be pumping anything if we don't have to.
Mhm.
Um, Remember the difference between the rim elevation and the flow line elevation?
Yes, the rim will change because of the size of the pipe, and then the flow line typically always stays the same because it's in the middle.
Flow line, you're right. Rim is what's at the very top.
Oh,
So if
okay.
that's yeah, so if that's on your so if you've got a paving area here, and then you've got a manhole, let's say right here, it's got a manhole cover on it, right?
Hmm.
That's your rim elevation right there.
Okay. On the video, on the how to calculate invert level video, they did RL. So is that rim what they didn't say what RL meant in the video.
Yeah, because I don't know what else it would stand for if it's not your rim elevate.
Rim level?
Yeah, it would have to be rim. I think it would have to be rim.
Okay.
But yeah, flow line is you're correct. Flow line is in the center, and then invert is at the bottom. IFR.
Okay.
Let's see. How do you calculate slope between two inverts? We've already talked about that. You can Google that. Um, it's just math, just doing math problems. Proof rolling. Remember why proof rolling is important.
Yes, because you need to see the compaction of the dirt, and if you need it, if there's too much moisture, it's not good dirt. If you need to bring anything else in, yes. I'm sorry. I feel like
You're
I mean I'm
good.
being tested, but I'm
No, I'm going to
nervous.
put you on the spot. I'm going to put you
Yeah,
on the
no,
spot.
that's
So,
fair. That's good. I'll be
um,
honest, because I'm not taking my notes, I should have gotten FFE right, but um the three
done.
unsuitable
So
subgrade. Oh,
is the proof roll done? When is it done? Before or after your compaction tests?
well, you do your proof roll before the compaction test, but sometimes you have to do the I'm gonna say undercut, but I don't think undercut's the right term.
Yeah, if you do a proof roll and it you determine that there's you and obviously we make the first determination, but it's confirmed by the testing lab
Hmm.
or the geotech engineer, whoever. And sometimes that's the same company. But so you'll do your proof roll, and then if it's determined that you have to take soil out, that's where your undercut comes in. You'll do an undercut of that area and then build it back up in your
Hmm.
compactions and your lifts at that point. You remember three signs that a proof roll is bad, that you do a proof roll and it's not good?
Well, I'm not gonna know the correct names, but I know if there's too much
Okay.
moisture,
Hmm.
and then when if it's not flat or if it does not feel compacted, and you can see in the photos that we saw,
Hmm.
um, moisture, and if there's any holes, would that be another one?
Yeah, absolutely. Anything that doesn't look, or if there's any organic material that you see. So,
Yes.
and organic's going to be tree branches, tree roots, tree, maybe there was
Oh,
a,
and rocks.
yep, rocks. So that happens quite a bit with trees. Maybe we took out a big tree that had a huge root ball. And then
Hmm.
when we go to start compacting and stuff, we get roots and organic material and we can't ever get it compacted right. So then we would have to undercut and take all that stuff out.
Hmm.
Um, let's see, remember three of the civil change orders?
Oh, yes. So, oh shoot. Okay. The change orders. Well, utilities is one
If you've
of
got it
them.
right, if you've got existing utility crossings, or maybe your existing utilities aren't where you think
Hmm.
they are, it's not where you think they are. They're definitely not where they're shown on the plan. Yep, that would be
Hmm.
one.
Um, well, and then you have the first three. There were a lot. But the ones that was utilities, existing utilities.
So you also had, so think about like when you're digging out.
Mhm.
So like any kind of groundwater, Could
Mhm.
potentially be a change order because you're going to have to do some excess dewatering. If you hit any rock, if you hit any kind of rock or substantial, a substantial amount of rock, that would be another one. And obviously, if you proof roll and it's not good, and you're going to have to undercut and bring that's another one. So those
Mhm.
would be probably your top three
Okay.
or four. Um, what evidence should a PM collect in week one field lab? Oh, that's when you're out in the field. So we won't worry about that. We won't worry
Oh
about that.
my
That'll be good.
gosh. I was going just based off of the videos I watched
I
yesterday,
know.
but now I know. Now I'm prepared.
Let's see. Oh, these were the video references. Let's see. A good PM leaves today able to navigate, da 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 da, explain. You will. Stationing doesn't matter. It's and watch, you'll get on a big project someday and that I'm not involved with, or and you'll be like, God damn, I knew I needed to know what
Yeah.
stationing was. I have never used it in 20 years. So, um, like I said, it's a survey deal. Build and walk a 7-step civil sequence. I think you'll get to that, and then so next time we're going to talk about we'll get more in depth on and that's where we may combine like a couple of I'll discard those, where we might combine a couple of levels, or a couple of lessons,
Mhm.
talking about, because we can, like I said, we can really get in on like the things I want you to know how to do are read a geotech report. That's number one. And maybe be able to look at a set of civil plans and just not feel like you're completely lost.
Mhm.
I know when I started, I didn't look at my first civil plans until I was probably 5 or 6 years into construction because we never built anything ground up.
Mhm.
So it was all remodels, it was all this. So it was just a completely new world for me, and it was
Mhm.
completely confusing. And honestly, I didn't understand it all I still don't understand every bit of it, but I didn't understand it all or close to it until I actually got out into the field.
Mhm.
But I didn't have YouTube. We didn't have any kind of training. We didn't
Yeah.
have anything. So that probably would have helped me a little bit. Um, what questions
So I
do you
had
have?
some questions based off of the videos.
Sure.
I'm probably, well, I don't know if I'll have any more questions when I rewatch this, but my plan is to rewatch this and take my notes, but
Hmm.
can't say I'll do that next time. I think I'll take my notes during.
It's okay.
But okay. So, well, one of them, and it's kind of tied into Training, but OSHA certification. Get
Hmm.
that?
Yes.
Okay.
Yeah.
Um,
You need your OSHA 30.
okay. Oh, my questions are on my computer. Share my screen. Okay, so for video one, which was the key tips for grading, this
Hmm.
is the engineer grading plan that we're provided, correct? This is not something I need to find, but this is something I need to know how to figure out and read. We already answered that.
Okay.
Um, well, looky here, finished floor elevations. Is this just on residential plans based on the video? The teacher's wording sounded like it may just be in residential or that's a specific term for residential, but no, it's in construction or commercial too.
Absolutely.
Okay.
Yes.
Would you recommend studying ADA standards?
Not right now.
Okay.
So
Um,
the only place that you need to be sure, so ADA does come into, it's very important, number one, but
mhm,
as far as in your learning, it's not like something you're going to encounter on a daily basis, or a weekly basis or a monthly basis. But where it is important with civil is for your sidewalks. So when you look at a set of plans, you'll have like a life safety plan
okay.
that'll show you like when somebody's inside the building, how do they get out? Is
Hmm.
basically what it does. So all of our anything more than a 2% slope on a sidewalk is too much,
Okay.
for wheelchair. So that's the most
Hmm.
important thing that you need to remember there.
Okay.
And also typically there is on the street, if we've got any sidewalks or ramps, if we've got a ramp on the street, they like to put in the, or we put in the, um, pavement. Well, now they make them in. We used to make them out of concrete, but now they have like a sheet. I forget exactly what they're called, but it's the bumps. So like when you go down a handicap ramp and you come back up it, you got the bumps that are in the
Yes.
sidewalk.
Yeah.
Well, that's for a blind person. So if
Oh,
somebody's blinded,
okay.
then or blind, they know that when they're going through clicking their thing, that if they hit that, they don't stumble and trip over it. So
Hmm.
that's kind of what that is for the
Okay.
people visually impaired. So
Okay. Um, in the video, he mentions a lot about typical slopes. Is this something throughout the entire world of construction that is a set rule, or does specific slopes change for state city codes? The word typical is used a lot in his explanation. So,
yeah, typicals used a lot. So typically it's 2% is like the
okay.
rule of thumb. That's the
Okay.
benchmark, so to speak, where we start. Now, some sites it's going to be less than 2%, but always more than one because maybe it's a really exceptionally flat site.
Hmm.
And where the existing sewer is, it's not low enough that, it's maybe it's a little too high for us to achieve that 2% slope. So,
Okay.
but 2% is usually the given.
Okay. Would you recommend Bluebeam University?
Yes,
Okay.
absolutely. So the things you can skip over on Bluebeam right now are like the online Bluebeam stuff. I forget what like where we can share jobs and markups and stuff like.
Hmm.
I forget what that's called, but we don't use any of that.
Okay.
But no, I would definitely recommend you going in and understanding like how to take how to do markups quickly,
Hmm. Hmm.
so that you can do them on like when we're on a call. That's the most important thing, right? You can take as long as you need to in order to do a markup when you're by yourself doing an
Yeah.
RFI or something. But if you're on a call somewhere with a design team, you got to might have to bring that up and be able to do some quick markups.
Yeah.
So you need to know where your arrows are. You need to know where your text is. You need to know where your bubbles are, your highlighter, basically the same stuff that I was able to illustrate here just on a rough,
Hmm.
and then you save your changes in a different file, and then you can go back and maybe clean it up if you
Yeah.
want to dress it up, make it look prettier,
Hmm.
because it will get kind of confusing sometimes if you talk about a lot of stuff. But yeah, so Bluebeam University, when it's specifically talking about the tools
Hmm.
and how to do that, and also how to dimension and those are the two things that you'll use the most often.
Okay. So I have a list of like Tranial, Procore, OSHA, and then Bluebeam. Like I'll
Yep,
throughout the time I'll start doing all of that too, or add that to my list of things.
perfect.
Um, is the highest point always the minimum low point? So in his video, the pond had a high point of, I wrote it down, of 76.45, and then the low point on the road was 76.45. So is that how that, because if the water gets to in the 25-year storm, the water gets to that point, the road's always at that minimum?
Right, correct. Yep.
Okay.
And that way it always drains. That way it
Mhm.
always drains. And that's usually the first thing that your civil is going to look at.
Okay.
So like you won't have to obviously, I mean, you're not responsible for verifying any of that, but that's kind of how they use it to gauge what the actual starting elevations are. And ultimately that's what gets them to the finished floor elevation. They don't start with that finished floor elevation of where it is. They always start with what the minimum is in order to get the site to drain, and then they work up from there.
Gotcha. Okay. Um, and then I asked on here, can you give me an example of how I would or could possibly use this in the field? But it would be more when I'm in the field and we're looking at the stakes and the grading of everything. That's whenever I would start utilizing all these tools.
Yeah, absolutely. And I think, I mean, obviously you can watch as many videos as you can find on it. Like it's the overall commonly it's all done the same way.
Hmm.
You stake it, you get a benchmark, you run some stakes out there, you provide some preliminary stakes, and that's with the guy that's going around, with the earthwork contractor kind of setting some preliminary stakes. They do all their rough cut, they get their proof roll done, and then you're kind of incorporating like, okay, we had a roof roll fail over in this area. What do we need to do for here? Maybe maybe we didn't. And then while they're working on that part of the site, maybe they're over here, digging out and they're starting to run their sewer line, or they're starting to run their, typically your plumbing is always going to go first, because it has to flow. It's gravity.
Mm-hmm.
So and that's the same thing in a building typically is of course, all your underground's already done once you've got the slab poured, but your plumbing goes first because everybody can work around the plumber.
Mm-hmm.
But if he's wrong and his stuff doesn't flow, then everything starts backing up, or you got to have pumps, or you got a big problem. So
Mm-hmm.
that's kind of the sequence.
Okay. Okay, perfect. And then video two, that was it for video one. Then video two was the calculating invert levels. What
Mhm.
does RL mean? And then an example of how to use in the field. Video two and video three were pretty self-explanatory.
Cool.
I understood on video one everything he was saying up until he started getting into the formula, but then I stepped away when I was watching it yesterday, and I just came back this morning, and it made more sense
Mhm.
of um, the low points minimum is the high point, and the multiplying the slope and adding it to the lowest point, all of that stuff. So
Perfect.
the videos made sense, and then I printed out the OSHA competent person requirements.
Okay.
So
Cool. Cool.
yes, but I just now, I mean, you really got me on the spot with that test. I'm paying attention, but gosh, I was like, but I would you share the PowerPoint with me? I'm a big
Oh yeah.
printer
Yeah.
printer out person. I have all my training notes and stuff in here, so I like to be able to print it out, and that would help me
Absolutely.
see the sequence and everything.
Yeah. I'll share the whole folder with you because I'm a week and kind of I've already got weeks 2, 3, and 4. See, over the next 4 weeks, it's 4 more weeks before we get out of civil, or 3 more weeks. I don't know that we need to spend that much time on it. Like I'm going to go through the curriculum and see if it maybe dial it down, not dial it down, but contain. Like I said, there's no sense in us getting way into the weeds on a lot of this stuff to kind of give you the, because you'll just have more questions whenever you go out into the field
Mm-hmm.
and you start actually doing some of this stuff.
Mm-hmm.
So let me share. Ba, ba, ba. There we go. All right, that should be the folder for the entire track. So,
Okay. And then if I was interested in getting some civil plans printed, would you recommend starting with Green Wave? Just because that's kind of what I would be shadowing on, or because their civil plans are a little bit more complicated?
um, yeah, no, I would start with Greenwave. That's fine.
Okay.
They've got two. So the two unique things there are the leach field, which is basically a septic system. So what happens is it pumps it into it, or goes in, it flows into a tank, and then the water's treated, and then it actually goes out into the ground. It
Right.
just filters out into the ground. So it doesn't go to a pipe, it doesn't go to anything. And the storm water is actually all captured on site, very similar thing. And the thing you can think about with the storm water, actually both of them, instead of having like a pond, like the one guy did in the elevation when he was talking about the bottom of the retention pond. So that's we got the same thing, except it's underground. Is
Okay.
nobody, and you can't see it.
Okay.
So that's kind of the same thing. It's more expensive
Hmm.
to do it, but it's also advantageous because that's literally our pay stations are on top of our stormwater detention. So
Okay.
that's underground. So yeah, no, you can certainly print those out. I will tell you, they're probably, because there's so much information in such a small area,
Hmm.
they're probably one of the harder sets that I've had to read. So
Okay.
yeah, it wouldn't hurt you at all to be able to go through and then take them and highlight them and kind of
Yeah.
point out some, you can see the different curb elevations, you can see the sidewalks. Something else to always pay attention on our car washes is to make sure that that sidewalk against the building is big enough, depending on the
Hmm.
vacuums we're going to have, so we don't
Hmm.
end up in like a Marshall situation where our vacuums are like, that far from the
Hmm.
windows, So, but yeah, no, absolutely. I would print that out. Sure.
Okay. Yeah, because when you were highlighting all of like the electrical, plumbing, all of the water lines, all of that, I was like, oh, I would just sit and while I have time, I guess,
Hmm.
to really sit and study and read plans for different projects, during, I guess, the 4 weeks or give or take 4 weeks of going over civil, just starting to look at them. I think that would be helpful.
Yeah, I completely agree. Yep, yep, I definitely agree. And you'll use that for, as we go further, you could just print out the rest of the drawings too and
Yeah.
kind of go through and like, because the thing I'll do is like when I'm on site, and I've still got to make a video for this, but like we'll take Greenway for instance. When I'm on site and I've got the big set of drawings on the trailer, not the permit
Hmm.
set, but I've got a separate set that I use for my stuff. I will actually go through here and I will physically take a highlighter on the page. And so say we set this one day, and then, first of all, everything would be in the one color highlighter for whatever I was doing. So
Hmm.
stormwater, if it was yellow or green or whatever. But then I would take it and I would actually mark right here. Oop, go here. So then I would actually mark right here and I would say, like maybe 4/6,
Oh, wait, I
26.
can't see your screen.
Oh, well, that's going to help. My bad, my bad, my bad. How about now?
Yes.
Okay, so what I've done is, and I would, like I said, I would physically do this on a set of plans. I would
Hmm.
highlight, so say we installed this in one day, we set that catch basin, we set that manhole, then I would come out beside it and I would actually write in red pen 4/6/26.
Hmm.
And then
Okay.
let's say, and then the next day, maybe we did this and maybe we did this. Then I would do the very same thing. And I would write, well, we did that the next day. So that was 4
Hmm.
7 26. And then maybe this was 4 8 26. But
Hmm.
that way, it one creates an as built drawing. And two, anybody that comes into the job trailer, or more importantly, as we run through the job, maybe something happens somewhere. And I say, okay, I need to look at my daily report for when we did that. Then I can, at least that gives me a little bit of a reference that I could go back, 6 months after the fact and be able to look that up.
Hmm.
So that's but I would certainly recommend, maybe going through and highlighting some, and it helps you too when you go through and highlight because it really calls out the stuff that's not highlighted.
Hmm.
And then the other thing that's difficult to read on a computer is as you're going through here, like this site legend here.
Hmm.
So this is all the crap that we have to install. And all it's just called out by letters and well, on this page it's all letters. So every
Hmm.
one of these you'd have to go through and say, okay, well, what exactly are we talking about here with D? It looks like it's just pointing out here
Hmm.
in the middle of nowhere. And we look and we say, oh, all he's talking about is the striping. Okay, all right, well that's fine. That makes sense. Well, what about E? What is this right here? And you go over and you say, oh, okay, well, that's a do not enter sign. So
Hmm.
that's going to help. Like when you buy out the striping for a job, you'll be able to go through and look at, and most of the time your civil is going to be done similar to this, uh,
Hmm.
just because it's very difficult for them to call out all this stuff.
Hmm.
So, um, but yeah, that way because this gives you a list of, okay, somebody has to be responsible for installing all this stuff.
Yes. Yeah.
And it's not necessarily like maybe the striping guy has, so he's got all your striping, right? So he's got that one, he's got that one. Let's say he's doing the signs too. So he's doing these signs. Oh, catch basin. Well, shoot, that's my earthwork guy. So that's a different guy. Manhole, that's a different guy. Light pole, that's the electrician there. Um, Positive limiting barriers. I'm not even sure what that is. So I would look here and try to find K, but that's kind of how I would go through a hard set of plans and start looking at it, right?
Yeah.
And at least start familiarizing myself. And not that I want to memorize it, but
Yeah.
you'd be amazed that as you're going, then when you start looking at scopes, you're like, I remember something about, there's something I need to include. And it'll take
Hmm.
you back to your notes and you're like, okay, yeah, that's right. He needs to pick up. Doesn't look like he got this sign that's in the very back of the site, maybe, or something like
Hmm.
that. So,
Hmm. Well, and I feel like it would help give me some sort of like if I were to go to this site and I have these plans that I've been reviewing and
mhm.
studying, I'm not going to show up and be like, hi, what are we
Exactly.
working on? Like I will know where things are and know how many signs there are. Just I don't know. As I've gone through this meeting, and honestly even with Tranial, I've made mental notes of things either that I would want to start at the beginning of the job so then it's easier during closeout, or
Exactly.
starting things. And like with this, like I could get 10 different colors and highlighters on the sign legend and then highlight each letter. I think having it in front of me, and once I get through the training and once I'm caught up on that, then I think I just kept telling Caroline, like, it's not that I'm like Tranial, I have really enjoyed Tranial. My hands hurt because I'm taking all paper notes. Like
Right.
every
Sure.
video I have tons of notes on. But I was like, I want to get through that so then I can move on to the next and I'm not having to go back to that and be like, well, I didn't pay attention in that video. I want to pay attention in this. So then I want to pay attention to my plan, like when I have the plans in front of me. So then I am retaining the information, and, that's why
Sure.
printing and writing on my notes is helpful. So I think having this, having a printed set, because then whenever I go, I can bring it, make my
Hmm.
personal notes on mine. So
Yep.
anyways, but
Yep. No,
yeah.
absolutely. And you'll, it's also going to be super helpful, especially on this site,
Hmm.
because we have so many manholes.
Yeah.
I mean, all of these are manholes. Every one of these.
Yeah.
We don't ever have that many. So,
Hmm.
but anyway, no, that's perfect. You're thinking about it, exactly the right way. So, um, cool, 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 cool. All right. Well, I think that was a great first lesson. What do you think?
Yeah, I think so too. I will be honest. I think I'm more prepared on what to expect, because
Okay.
when I was watching the videos, I was like, oh, this is easy. I'll these videos we'll just go over our notes. But I mean, it was tough. Like the questions are tough, but it's just because it's all new.
Right.
But some things I do think it is helpful that even though my experience is little, that I have some experience of seeing projects start car washes only, but from the beginning of civil to
Yeah.
the end. So,
Yeah, and the car wash experience will serve you good because it is fairly heavy on the
hmm
civil. There's
hmm
there's a lot of projects that you don't have these big old reclaim tanks that have to be piped in,
hmm
or you don't have a storm system that's completely underground. Everything's just maybe run to the city from one catch basin. Super
hmm
simple. Um, another something else that might help you with the civils too is the Brownwood project.
Oh yeah.
That one was very extensive and he had to do a lot of work with TxDOT and everybody else, but kind of reviewing that
hmm
as well would also just give you another kind of, yeah, I guess a different look on because that's more of a like a development, right? So
hmm
not where we're not just developing one site, but we're developing two and prepping for a third.
Yeah.
So it can be, that can be beneficial as well. So
hmm I actually just threw those plans away a few months ago because I had them at the home office, and
yeah.
then when I moved out, I just was
Oh,
like, oh, I
sure.
don't need these anymore. But yeah, no, that one, I remember that was a lot. Do you feel like when, if somebody were to understand civil, not that it's going to be smooth sailing the rest of the way, but civil may be one of the harder things
Mhm.
to fully understand?
Yeah,
Okay.
absolutely.
Okay.
Absolutely. Because not everybody does civil. Like
Hmm.
it's not, about half your projects are either ground up or they're remodels. And if they're remodels, you never even touch the civil. You don't even worry about
Hmm.
it. And it'll also make you appreciate some other jobs where you don't have to mess with the civils. You don't do anything
Yeah.
outside the building, and you're like, okay, well, this is going to be a breeze then getting this thing done.
Hmm.
So,
hmm
but no, absolutely, yeah.
Okay.
So
Okay. Well,
cool.
awesome. And then the next meeting you invited me to, so is
Yep.
this
So this is an OAC meeting for Nature
okay?
Med. So you're just basically gonna log in and or listen pretty much,
Okay.
kind of what we go through, kind of a standard OAC meeting when we're meeting with the first one's going to be just with ownership. And then I don't think I invited you to the next one because it'll get long-winded and you'll get
Okay.
what you need out of the first one. So
Okay.
talking with ownership and kind of running through our schedule and that kind of thing. So
Okay.
all right.
Okay, perfect. Well, I'll see you in just a second on
All
there.
right. Sounds good.
Okay.
Bye.
Bye.